just missed the puppy, but that, whatever that is, what is that? Tiger, is pretty cute too. So just did the little, for the next couple of weeks, and we've got 2 single lessons this week. Next week we have, oh my God, we have all 4 of our lessons. So the double and the singles. But then week 6, we only have our double. The Thursday, there's a question mark about, would we be ready for a test? Wait till we finish this week and next. Otherwise, your test will be Thursday of week 7. That means you have 1 day, 1 lesson to revise for your exam, which is then on the Wednesday of the following week. Okay, so it's really important that we are I don't think we're going to have to go speed demons, but we do need to make sure we use our time well, and that includes our homework. Okay, this is very nice work. Now, on Teamies, whatever, if you go into there, let's have a look with the program. Don't know where it went. No. Now see, on mine the program shows what is going on. Program outline, equation of a line, text reference, program. Mine shows. Does yours show? It was on mine. This is where I go. Anyway, you look on yours. What we should have, we should be up to simultaneous equations, which should be revision. So I'm going to put a little video on whatever. You're going to have to look at that over the weekend. That'll be Friday night's homework. Today is quite nice. However, before we get into that, are there some questions from homework? Which one? With question 5 from the B, whatever. So we've got part A or part B, all of it?
I think I've got part A.
So find in gradient y-intercept form the equation of line 2. So we should be going, what 2 things do we need to find the equation of a line? Remind me. Slope and a point. So we have the point, huzzah. But if you're just looking here, we don't have the slope, but then you're looking, what information do I have? Those little arrows mean parallel, so it's got the same slope as this, and this is already very nicely in the correct form. So what is the slope of this line, of line 1? 3/4, so that's going to be your slope of line 2. Do we need a refresher of finding the equation of the line, or we're good? People are shaking their heads. Good. Hence, find the y-intercept of line 2. Oh, how sad. So how do we find our y-intercept? Anywhere where it cuts the y-axis, what is your x value? 0. So to find your y-intercept, make y... Did I say that? To find your y-intercept, make x 0. To find our x-intercepts, we make y 0. You wouldn't have to bother when it's in this form, because we know when it's y equals, bang, 1 would be our y-intercept. More than one way to do stuff. Does that make sense for you or not? Okay. Yes? So I'll come and have a look at yours, and I will be looking at your homework. I'm not impressed that we're so late, people. You will be explaining to me and probably visiting me at lunchtime. Okay, what about 6? Yep. So find in general form the equation of line 2. So who would like to take that over, please? If you can't explain it simply, you don't understand it well enough. It looks like I'm pointing at Hamish, but it's a sign behind you, Hames. Right? Who was that? Albie Einstein. So again, when I'm reading this, I want to find the equation of line 2. So I'm saying to myself, what 2 things do I need to find the equation of a line? Point and a slope. So I look, I go, oh yay, I've got the point. So good, so good, so good. But I don't have the slope. How can I get the slope? I'm looking. What 2 things do we need to find the slope normally? I do this to you. 2 points. Oh, I do have another. Are we doing which one? Oh, line 2. All right, sorry. I've got 1 point, but I do not have another point. How sad. But then what's this going to do? What is that saying? Perpendicular. And what do we know about perpendicular slopes, peeps? Right, so, Quiche, if I knew that this slope, by the way, what sign would this slope have, line 1? Negative, because it's decreasing. We know it's going that way. So these are just little things we know, common sense, so our answer will be reasonable. Can I find, well, if I find the slope of that line, let's say it's negative 2/3, what would have to be the slope of that line? Now, Dylan was going negative reciprocal. Yeah, flip and reverse the sign. Yeah? So then it comes down to, can I find the slope of this line? Yes, because I've got 2 points. Okay? Oh, well, then it's probably just a little, negative gone amok. I'll come and have a look. Well done for asking, and well done. Once we do that, we'll go on. Okay? We good? All right. So, people who came late, the simultaneous equation part of stuff is going to be for you to look at over the weekend, and if you're not happy with it, we'll check it on the Monday. But what we want to do today, I know it's late in the week, you've been a bit crook, you're going to be doing some very, very pleasant mathematics. And someone's going to tell me that maybe there was a accident or something out there. Okay, I shouldn't be happy about that. But lots of people have been late. So I'm not hoping that someone's had an accident. I'm just going, why is everybody late? But that's okay. So if you're looking at the outline, which hopefully you see, I don't know why it's not coming up on my screen before, 3A. I'm going to do this very quickly. You're going to make a note. Not too quick. Basically, we want to know what is the difference between a function and a relation. And relation, not like auntie and uncle or mother, father. Come on. There we go. There we go. Oops. All right. So, for starters, relation. So I don't have to get too fancy pants with this, but basically when we're connecting two variables, so x and y, right, we get y equals 2x plus 4, straight line. That's a relation. We can have our good old y equals x squared. It's a relation. We've got this one, x equals y squared. It looks a little bit like this, like a pushed over quadratic, yeah? So these are relations. We've got equation of a circle, right? A circle, that is a relation. Happy with that? If we've got x, y, z, no, we haven't got a relation. All good? A function though, so here we go. All functions are relations, but not all relations are functions. Now this is going to be very hard to determine whether something is a function or not. We ready? Very difficult. You take a vertical line, could be a ruler, right? And you pop it along, you can't see that at home, but you just pop it along. And if it cuts your graph once, it's a function. If it cuts it twice, not a function. I know, tricky, huh? So a function, vertical line test, cuts it once, huzzah. So this one, is this a function? Yes, because anywhere you put your vertical line, it will only have one value. One x value has one y value, correct? But if we go over here, oh dear Charlie Brown. Because if I pop that there, I'm going to have two cuts. So that is not a function. So it's not a big deal. We happy with that? If we go back over here, so vertical line test, I'm going to pop there, and hopefully you know. So an x value You don't have to write this next line if you don't want to. Has only an x value only has one y value. Are we good with that? Nothing difficult, nothing to see here. And I don't think that you need to actually draw any of this stuff. Don't worry about number 2 for now. We'll come back to that. But if we're looking at these functions, these relations, not all of them are functions. So is A. Say yes or no together. Yes. So yes for function or no. Yes. Vertical line. Yes. 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 Right. Only cups. What? You'll see this later in the year. That's your normal distribution curve. Oh, that's a yes, no from everybody. Sorry, people playing at home. I wasn't saying it. So, yeah, they all got yes, 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 no, yes, no, yes, yes, no, yes. And then this one became, ooh, K was like, ooh. So, up until this point, I'd say yes, yes. What do these dots mean? So, the dot here means it can be that value. But when it's an open dot, it means it's up to it, but it can't actually be that, right? So far, it's a function. It's a function because we haven't got 2 y values for 1 x. So all good, still all good. Ooh. This is where it breaks down because, I don't know, if x is, let's say, 7, you're going to have this y value and you're going to have that y value. So that's going to be a no. Does that make sense? So it was all good. And then it got to that bit, no. Because you got more than one y value for an x. Is that okay? Yes. Vertical line. All good. Happy with that. So nothing to see here with relations and functions. 3A, done. Oh, actually, I was going to say, just the last bit, there was an explanation, but we don't have to write anything down. Yes, vertical line, beautiful. I did like this question. Is it possible for a function to have more than one y-intercept? Why? The answer was no. Why not? Yes? What do you mean overlap? Like it's good, just, yeah. Right, we just said before there's only one y value for one x, one y value for one x value. So if you've got 2 y-intercepts, it means you've got 2 different y values for when x is 0. Yeah? That's what you're trying to say. Well done. Will the graph of a straight line always be a function? When the slope is undefined, yeah, so when it's vertical, because then you've got lots of different y values for one x value. Agreed? Okay, just makes you think. I like these questions. That's probably about it. There's one about the weather. I think I've skipped that, but that's okay. Where was the weather? Did we see a graph with the weather? Doesn't matter. All right, so onward, to something that I think you have already seen, function notation. No. So, this is just a fancy pants way of saying y equals, right? So I'll just write that. I thought I'd cut and paste this. I'm trying to go to OneNote so it saves and I don't have to keep double saving, but my computer's playing funny things this morning. So we've got Is it plus 3? You might have seen this as y equals 2x plus 3. All means the same thing, and there's one other version that you might have seen. Anybody know it? Anybody know it? F of x. And this is probably the one that I like the most. But it's just trying to go, we're looking like we're a bit smarter than we actually are. Trying to scare the English teachers with symbols, putting those letters in. Okay, but all of this just means, yeah, y equals. Okay. All groovy? Can you all see this? This is on your page 67. Okay, so now we're just getting into, you're going to be upset if I write, oh, I can change my colour. Let's change my colour. What would you like? Purple? I don't know if that changed it or not. Yes, it has. Okay, so what does this mean? Yep, it's saying wherever x is, I want you to replace it, wherever x is in here, I want you to replace it with 0. Okay? So we're going to go f of 0 equals, and this is our rule, so this is the function that we keep going and looking at. If there was a second function, guess what they call it? G of x. If there's a third one, h of x. They might call one little f, then another one could be capital F. You would have seen it in our last topic. Sometimes we had p of x. P for polynomial. That's right. Okay, so this becomes 3 times 0. Minus 0 squared plus 2. And you should be going, geez, Mac, why are you even writing all of that in? Because we know 0 times anything is 0. 0 squared is 0. So we should know that this is actually just 2. If we're talking about a graph, this gives me the coordinate, what? 0, 2. Correct. And that's a very important point. It is, in fact, the Y-intercept. That's good. So what is this saying? Wherever x is, now replace with 3. What is this one saying? Replace with negative 3. So you're going to go and make sure that when you square a negative, what do you get? A positive. And you know what? Try and do it without your calculator so that you do know that minus 3 squared is 9 and not 6, as some of you would have me believe. So you're going to go through, get to the fraction for sure. Use your calculator. So can you go, give you 5 minutes, hit that. Working your way through. But what I want you to be very aware of is the difference. The difference between this question or this statement and this statement. Okay? Don't then just go, oh, you know what? They're the same. That's got an F. That's got an F. Close enough. Right? This is very different. That is not equal to f of minus 8. They are two different statements, and yet we get students mixing them up all the time. So what is this one saying? This is saying put x in, replace x with minus 8, and then you're basically solving for y, correct? This one is saying the whole function equals minus 8, and so then you actually want to solve for x. Can you see the difference? And it's about reading the maths, not going, oh yeah, it's close enough to what I had to the previous question or the one I did for homework the other day. So, let's have, this is not in the book, just adding, ad-libbing. So what will we do? Do we know what f of x is? This is for question 1. Do we know what f of x is? Yeah? So we pop it in. So this is, you haven't done a question like this before, but you're reading, you don't know what to do, but you go, well, I'm going to be desperate, I'm going to do something. So what is f of x? Well, we're going to replace that with the thing that it says it is, 3x minus x squared plus 2. And then what do we keep saying? Equals negative 8. Whoops. And now hopefully we shouldn't be able to help ourselves because we go, oh, what do we see here? What is that? It's a quad. And so we're going through, doing it again, girls. We're going through and we go, when we see a quad and we're trying to solve for x, what do we have to do? Get everything on one side. Now you've got an option. Do you want to bring the minus 8 over? Yeah, see, I don't want to. People were saying yes. Do you know why I don't want to? Because I've got a minus x squared, right? You could absolutely bring it over. I'm just really sucky at trying to factorize if there's a minus in front of the x squared. So I'm going to just chuck it all on the other side. It's not a guarantee that it could factorize, right? If it doesn't factorize, how would you then solve it? Quad formula. If it didn't say do it algebraically, what could you do? Calculator. Oh, yeah, you could graph it. I would go equation on the calculator personally. So the minus x goes over. We get x squared. The 3x goes over. It's minus 3x. Get rid of the plus 2, take 2. It's minus 10. And before we go quad formula or calculator, we go, hey, are there two numbers that times together gives me minus 10, but adds up to be minus 3? Yep. So we go x, we go x. 5 times 2 has a difference of 3, and of course, minus and plus. You won't leave it like that because they're actually asking you find x. So you would then say, huzzah, x equals 5, x equals minus 2. Okay? Obviously, if my function wasn't a quadratic, if it was linear, then how do we solve a linear function? What's our game plan? Not everything on one side. We go. So do you know what I mean when I'm saying linear? So if you ended up having something like 5x take 4 equals 9, how do you solve that? X is on one side, non-x is on the other. We don't do everything on one side. Yeah? So that's what will be coming. So could I ask you, Petals, without too much talking, can you now, heads down, and see if we can finito petito, question 1, question 2, right? Oh my goodness, instead of F it's G. Same thing. See how we go, all right? Let's go. Okay, couple of people thanking you. Oops. Shh. Apart from a couple of people at the back, the rest of us should be listening if you like. So we've got the graph of y equals f of x. It's like, yes, so we're not worried. They could have just said the graph of y. They could have just said the graph of f of x. They're just making a point, heavy-handedly, y equals f of x. Good on you. But that's our function. And they're saying find f of 2. So remember we talked about this is actually the coordinate. So this is your x value. So they're saying when x is 2, what's y going to be? Now, when we actually have the equation, we subbed it in, correct? Here, we've got the graph. So it's saying when x equals 2 here, what's y going to be? 1. So that means that is 1. And that is equivalent to f of 2 equals 1. That's what it means. When x is 2, y will be 1. That's what this means. When x is 2, y will be 1, or f of x will be 1. Capiche? Right? So what's f of 3? -1, that's right. So here's 3. Go down, that's -1. So f of 3 is -1. Find the value of x such that f of x equals 4. Again, that's equivalent to saying when is y equal to 4, right? So here is y equals 4. When does it cut the function? -3 -4. So we'd say for this one, x equals -4. If that was me, I would probably draw that little sketch in my book to actually show, right? What do these little things mean? It's really important that you do understand that interpretation. You want me to do that again? Because were you not listening, tuned in? Yes, that's what we have to listen the first time. We'll do it again. You just substituted with numbers, Amara, Jazz. You just substituted with numbers. Now, can you do it if you substituted it with letters? Why are they wanting you to do that? Oh, just to make sure that your substitution is beautiful. Beautiful. And when we do a little bit of higher math, sometimes you have to substitute in some crazy values. So, are we watching? Because we don't want to have to do it twice. So, we've got f of x equals 7 take 3x. If I said to you, find f of 1, what would you do? 7 minus 3 times 1, correct? So we get 7 take 3, we get 4. Well, now they're saying, well, can you do it when you've got f of a? So again, what is that saying? Wherever x is, just replace it with a. So it becomes 7 minus 3 times a, which is 3a. Coops, I could ask you, replace it with a star. You are a star. Right, 7 minus 3 times star. You're just, wherever x is, replace it with what's in that bracket. Capiche? Right? Yes. Does that look ugly? Sure. But hey, it's not difficult. It's just saying, can you follow and apply the process? Do you understand that this just means wherever x is here, replace it with that doohickey, a plus 3. Can we tidy up? Of course we can. 7 minus a minus 3, you're subtracting all of that. 7 take 3 is 4 minus a. Right? If you looked in the back of the book and they had minus a plus 4, you wouldn't rewrite yours. You'd just go, yeah, baby, they're the same thing. It's 7 take 3x. Sorry. Bad me. I thought it was 7 take x. Bad me. 3 times x. What is x? A plus 3. Apologies. So, expand your bracket. I was just making that one up. Take 9. We get minus 2. Take 3a. Capiche? Oh, thank you, Hamish. Should we do one more just in case because I stuffed that? Pick one. Anyone? No? They want to do their own thing? Carry on.